Well, hello students, good day. This is set theory number 5, and we're going to work on the idea of counting and finding subsets of finite sets. Later on in the video we'll talk about subsets of infinite sets, but that's really a separate topic, so we'll see how much time we have. So below we have the set A, B, C. Can you name all subsets with one element? Can you write those subsets down? Why don't you give that a try? That's right. The subsets are the set A, the subset containing B, and the subset containing C. So those are all the subsets of our original set. We'll call it set A with one element. How about if we did it for two elements? Can you give me all the subsets of two elements? Exactly. Here they are, the set containing A, B, the set containing B, C, and the subset containing A and C. And it's okay if you got these in different orders as long as you have those three subsets. So these are all happen to be proper subsets of set A, but as you can count, we see that there are 6 of them. Are there any other subsets we didn't list? That's right. The first subset is the subset of 0 elements. That is the empty set. And then also the subset of 3 elements, which would be the actual set itself, set A, B, C. So the question is, how many subsets do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. And notice the organized fashion with which I work through it. Are there any subsets of more elements? No, because we'd just be repeating these, and that would be the same as this. And there's no subsets less than 0 elements, so the empty set's the minimum we get there. So we have 8 subsets for a set of 3 elements. If I change the elements to say 1, 2, 3, would the nature of my subsets change? Not at all. I'd have the set 1, the set containing 2, the set 3, 1, 2, etc., etc. Okay? So this leads us to an idea. We have 3 elements and 8 subsets. So how do we connect all of them? And that's the key idea for this next slide. So our theorem for today is a formula for finding how many subsets you have of a given set. It does not tell you what the subsets are. You have to find those. But it does tell you how many of them there are. So the first subset, the theorem says, the number of subsets of a set with n elements, in other words, its cardinal number is n, the number of subsets is 2 to the n power. Now, we had a set with 3 elements, right? That was set A, which was equal to A, B, C. And how many subsets did it have? Well, it had 8 subsets. And now we know why it has 8 subsets, because that is the cardinal number of A is 3, and so it's going to have 2 to the 3rd power, which is equal to 8 subsets. And that's why we ended up with eventually 8 subsets. So the question is, how many of those subsets are proper subsets? Well, it's an easy question. All you have to do is throw out the set of 3 elements, and then every other subset would be a proper subset. So the number of proper subsets would be 2 to the 3rd power minus 1, or 8 minus 1, which is 7. And that leads to another formula. If you change this theorem to, let me do this. So here we go again. I started and I got a little stuck. You probably heard me say So I'm trying to edit as Gustavo asked me in class yesterday. So here's what I have for you. We're going to take this and we're going to shrink it up, and that's what we have. The other theorem then that compares to this looks this way. It would say the number of proper subsets of a set of size n is 2 to the n minus 1. Now notice you're not subtracting in the exponent but just below. And as we showed earlier, where we had 2 cubed minus 1 and got 8 minus 1 equals 7, that's the number of proper subsets. So what I want you to do is I want you to do a couple of problems where you get to practice this idea where you find the number of subsets. Okay? So here's a couple of sets, and what I would like for you to do is find how many subsets in each case. So how many subsets does set A have, and how many subsets does set B have? So hopefully you paused for a moment and you did this. And how do we do this problem? Well, let's look at set A first of all. What I look at first is I see that the number of elements in set A is equal to 5. And since the number of elements is 5, then the number of subsets is equal to 2 to the 5th power, which is equal to 32. And now if I go to set B, I want all the natural numbers between 10 and up to 20, but not 20. So those numbers, I got to figure them out. That's 10, 11, 12, 13, up to 19. And so the number of elements in set B is equal to 10. So the number of subsets is going to equal 2 to the 10th power, which is equal to 1024. Alright? So that's how you do those two problems. So let's switch gears. What if I wanted to find proper subsets? So we'll do this in red. Well, the number of proper subsets would just be 32 minus 1, which is 31. So we'll say number of proper subsets there, and the number of proper subsets for this one would be equal to 1024 minus 1, which is 1023. And that's how you do finding subsets, how many in each case. Now that leads us to another, and the issue is how do you actually try and make a list of how many subsets? So I'm going to show you with a slightly bigger set here how I would do it if I had to not only find how many but actually write them down. So, for instance, I already know that there are 16 subsets, okay, in this case. So what I do is I notice that the number in the set is 4, so I'm going to look for the subsets of 0 elements, 1 element, 2 elements, 3 elements, and 4 elements, just like we did before. And I'll do the easy ones first. This subset's the empty set, and the subset of 4 elements is all 4 elements in a set. So now how do I do these other ones? Well, what I would like to do is I would like to list them, each set, 1 element at a time. And that seems to work out pretty easily. And then now I want to do it 2 at a time. So the best way to do this is to start with A and then attach everything in the set that can go with A. And now you see A is attached with B, C, and D, and there's 3 subsets. But now I want to take B and attach to it things that are different. So I can't attach A because I've already done it. So I do B and C, and then B and D. And then I go to the letter C, and I can't attach A or B to the C, so I'm just going to start with D. And if I go to D, I notice that I've done all the D's, all 3 of those. So each letter has 3 possibilities with it. But some of them, they're all counted twice, depending upon what you do. But there were 6 subsets of 2 elements. Notice the order in which I do it, and that'll help you keep track. Now you follow sort of the same path with 3 elements. I do A, B, and then I attach C, and then I do A, B, and I attach D. So then I go to the next 2 elements, which are B, C. Notice I already have A with it, so I just need to attach D. And then if I go to CD, I can see that I already have B attached to it, so I need C, D, A, and I attach that. Whoops, my D looks like doesn't look like an A. So there's A. So now we've got that corrected, and that gives me all my elements there, and I have it in essentially an organized fashion to find what I need. And you'll notice that AB is in 2 sets, BC is in 2 sets, CD is in 2 sets, and if you wish, AD or AC are in 2 sets, and you can go through that. And if you count these up, I have 6, 4, 4, 1, and 1, and that adds up to 16 subsets, which I found. So this is a technique you need to know, especially when we get to sample spaces and statistics and some probability problems. So just to finish up this video, your textbook finishes with an explanation of what we talked about the other day. Call it Aleph naught, and I just looked up the symbol Aleph 1. You remember different kinds of infinities. This is the infinity of the natural numbers, whereas this is the infinity of the reals and the irrationals. Your book has an explanation. I want to encourage you to read page 64 and 65 on your own. And if you have any questions about it, I would like for you to ask those questions. I may assign you a problem or 2 on Aleph naught or Aleph 1 just to see if you can do it and if you can think about it. So that's everything for section 2.2 in your textbook. So our problems for these are going to go from problems 37 all the way to 91. And I'll have those ready for you in class tomorrow. Thanks. Have a good day.